find the arc length along the polar curve, r theta equal to e to the minus theta. So theta goes from 0 to natural log of 2. First, we write down our formula for arc length. Arc length equals definite integral from angle 1 to angle 2, the square root of r squared plus r prime squared d theta. Where does this formula come from? In case we need to rederive it. So, think about your limit process for integration. Here, we're integrating over the variable theta. So we're looking at, our polar curve, which is going to vary as the angle varies. So what we're going to do is take a look at our region of integration. We're going to chop it up into lots of tiny slivers. So these slivers, usually you would have rectangles, but now they're going to be tiny pi wedges. So we're going to take one of those pi wedges. We're going to take the 2 points that are on the curve. We're going to approximate the arc length of the curve by taking the straight line segment between them. Take that thing's length. We'll call that delta L. Then we'll sum up over all of those delta L's. That's going to give us a number. We take the number as all of our little wedges. Their angle goes down to 0. That limit exists. That's what we're calling our definite integral. Let's look at the picture for one of these tiny pi wedges. So what's happening? We have our curve, goes through 2 points, theta 1, r1, theta 2, r2. So we're going to have point here on the curve. We draw on the straight line segment. That straight line segment, its length will approximate the length of the curve between our 2 points. So next, we want to figure out how to calculate the length of the segment. So the idea is going to be, let's label some things. So theta 2 minus theta 1, it's going to be this angle here. We'll call that delta theta. Then this segment here, notice that's going to be r2 minus r1. We'll call that delta r. So if you notice, this is almost a right triangle. So I know we want delta L. We have delta r for one of the legs. The other leg I need to find. But that's just going to be given by radius. This is going to be an arc on a circle. So I just need radius times angle. Radius is going to be given by r2. So the angle given by delta theta. So the length of that arc is r2 delta theta. Now I can apply the Pythagorean Theorem. So I'll have delta L squared equals r2 squared delta theta squared plus delta r squared. So right here. Now, we can take square root of both sides to get delta L. That's the delta L for this little piece. So I'll label it with an I, and then we're going to take a whole bunch of these and then sum over them. Now, as I look at these, notice I can factor out a delta theta sub I squared. So we bring it to the outside. That's going to give us terms r sub I squared and then delta r over delta theta I squared. As delta theta I goes down to 0, delta r over delta theta I is going to go to r prime. So as I take the limit, as the delta thetas go down to 0, so this is our limit process for integration, what happens? Well, the sum becomes an integral, delta theta I becomes d theta, and then for ri and delta r over delta theta I, we're allowed to drop the i's. So I'm left with our formula for arc length. Now let's compute our definite integral. So what do we have? We have r theta equals e to the minus theta. If I take the derivative of that with respect to theta, I'm just going to get minus e to the minus theta. We just take the derivative of the exponent with respect to theta. That's a minus 1, so that comes down. Then we just stick things into our formula. So we're going to square both of these, add them together, square root. So just squaring is going to get rid of your minus sign, and then these are going to be the same exact term. So that'll turn into 2 e to the minus 2 theta. Square rooting that gives me a square root of 2, and then square root of e to the minus 2 theta. Well, square root is exponent of half, so the half and the 2 hit each other, leave me with a minus theta. I'm going to take the antiderivative of this. So antiderivative of e to the minus theta. Okay, well that's just going to be itself, and then I flip over by the constant in front of the theta. So that's going to be a minus 1. So antiderivative is minus e to the minus theta. Okay, we're going to go from 0 to natural log of 2, and I have a square root of 2 out in front. So if I put natural log of 2 in here, that's going to give me minus e to the minus natural log of 2. Okay, now what I can do here is I can pretend there's parentheses. I'll have e to the natural log of 2 with a minus 1 on the outside. So the e natural log of 2 collapses, leaving me with a 2 to the minus 1 or a 1/2. So this term here is going to be a minus 1/2. Then if I put 0 in, we have e to the 0, which is 1, and that's going to have a minus sign in front, so it's going to be a minus 1. So we have minus a minus gives me a plus 1. So I have 1 minus a half gives me a half, and then I have the square root of 2, so we get square root of 2 over 2.